All right, let's take another look at biasing this 1959 Fender Harvard. The last video was really more geared towards empirical use of a decade resistance box when you're kind of trying to walk your way into some values. But, you know, the negative 27 that's on that Harvard schematic doesn't factor in a number of things. Actually, it doesn't factor in the difference in wall voltage that we have today. It doesn't really factor in drift of components or the current draw of tubes. So we're going to look at plate dissipation and how actually this same method of deriving a value from a decade resistance box can actually play into the math of calculating plate dissipation. So what I've got, and again, this is an iPhone video, so it's going to be a little shaky, moving around a little bit. Oh, a little Christmas present, I guess. Combination of things. Alexa, turn on light. So I got this Luxo KFM LED desk lamp. I've been my old one.
KFM LED?
No. The robot from Amazon heard me say something that she thought was a command, and it wasn't. Anyway, my old light was giving out, and so this one is awesome. Stays in place. The LEDs are good and bright. It has a 5x magnification, which if that were closer would look nice. So anyway, let's look at this. What I have is instead of the decade resistance box hooked up, you can see that it's at the times 10,000 is at 3, the times 1,000 is at 9, so it's at 39K right now. And instead of using that, I actually went to my pile and I've got a 39K 5% quarter watt resistor that I just have jumpered into the circuit here. All right. And so while we're doing that, oh, and when I say jumpered in, I mean I've got some flying leads there where the resistor would normally go, and I've just got the leads, kind of jumpered in to tacked, soldered in, tacked up leads. Anyway, so to actually look at the plate current, I have one lead of my multimeter connected to the output transformer center tap. That's where the black one is. And then the red one is on the plate of this, I guess it would be V3 on this amp. So something that you guys need to know, and by the way, all of this knowledge that I have about this is a direct result of Uncle Doug's videos and El Paso tube amps. I love those guys. Those guys have forgotten more than I'll ever know, but they have really helped me immensely. And so this is not stuff that I made up. I got it, off of watching them and reading and watching other videos. But one of the things that you need to know, and this is something that that El Paso tube amps really stressed and kind of made me aware of, is that when you're looking at current with a multimeter, this is a wire. So if I were to unhook this red lead here and I still have the black one connected and it's in circuit, these are alligator clips, so it's less likely that this would happen. But I don't like to use handheld probes when I'm working with current measurements, because the leads are a wire. And if you get in the middle of that, if one is still hot and the other one you touch with your hand, you're in that circuit now. It's not the same as measuring voltage reference to ground. Measuring current is a whole different animal. So if you're going to do it, be careful. And if you're going to do it, I really recommend setting up a clamp probe, turn it on, take your measurement, turn it off to move it. That's the safest way of doing it by far. So anyway, enough talking. 39K resistor in circuit. If I flip this on, we will see that the meter will go, and I've got these leads reversed, so it's going to show negative, but and it'll go to right at about 28 milliamps. That's where it's going to sit, is right in that 28 range, and it'll kind of bounce around a little bit, just, you know, line voltage and other factors, but 28 milliamps, so 0.028 amps. All right, so let's turn that off, and I'm gonna disconnect the leads here. Sorry for the shakiness again, but I get this right. All right, there. Flip this probe around so we can measure volts. Hook up our plate lead again. It's hard to do this with one hand, always is. Fender gave us a nice little ground strap there, which is easy to use. Okay, so we'll flip this back to DC volts. And we've got black on ground, red on plate, and that's set to volts. Okay, good. And we've still got our 39K resistor in circuit here. So flip that on. You can get, you know, a little inrush spike of voltage there, and it'll drop back down as the tubes start drawing current. And we're going to be, you know, right in the 355 neighborhood, somewhere in there. I want to say, and I had my book earlier when I was doing these measurements, and I think that that this settled in at 359 volts earlier, and it's a little bit lower now. Again, I think just wall voltage. That's the thing about wall voltage and transformers, you know, I mean, that 3 or 4 volts seems like a little bit of variance, but when you've got a turns ratio in a transformer, just a little bit of difference in wall voltage makes a reasonable difference, you know, on the other side of a turns ratio of a transformer. So we'll call it 357. That's really where it sits now. So to do plate dissipation, you would multiply 357 times 0.028, and let me get a calculator, and I'll be right back. So I'm back. Yeah, so it's right at 358 volts now, which is, you know, really what I measured it at earlier, just kind of letting things warm up. You know, it bounces between 357, 358, but it's kind of closer for the most part. Anyway, anywhere in there, times, you know, if it's 356, 57, 58, times 0.028, so you're just multiplying plate voltage times plate current, and you're getting the plate dissipation, which is right at 10 watts. And so for these, you know, JJ 6V6s, 6V6S, their max is 14 watts. So, you know, you're really kind of comfortably in that 70 to 75% range for that bias value. And this, I know it's upside down, but you can see that the I think I got these from either Tube Depot or Tubes and More. I can't remember. Oh wait, it probably says on there. No. But these are Apex match, so it must be Tubes and More. So the transconductance is 3430. The current's 42. So you know, if I put this 39K resistor in circuit and all things being equal, you know, I can order tubes from them that have a current of 42, which I think you can be that specific. You know, it should be pretty dependable, the results that you're able to get out of an amp like this that is, you know, fixed bias, and that, you know, if you have a good matched set of tubes, which these are from a current draw perspective, which is what matching is, then you'll be in good shape. So again, couple things here. A decade resistance box can be really helpful in again the empirical method of just trying to kind of figure out what's going to work best in your circuit. Don't just look at the old Fender schematics and treat that as gospel. You know, that in that previous video I showed how you can use it to get the negative 27 volts DC that the schematic recommends or says, but that's not gospel. You know, what's most important is figuring out your plate dissipation, making sure that your tubes are going to be healthy and you're going to get as much longevity out of them as you can. And you do that again by taking a current measurement of the plate current and the plate voltage, and then that is your plate dissipation. And again, just can't stress this enough. When you're measuring current, be very, very careful. There are other methods of doing this, like you know, 1 ohm resistors that you're measuring against. You can do it using a bias probe, which I've got around here somewhere, where you actually, you know, put the tube in that socket, and then you are you know, putting that into your multimeter. So those are great options as well. I find this ability to measure plate current against the plate and the center tap of the output transformer is really fast and reliable, but it's also, you know, there's some inherent danger to it. So y'all be careful. Get one of these Luxo lights if you're in the market. Really good. It's LEDs, and that, you know, it's dimmable. And I've got it set up with my Echo Dot and a TP-Link switch down there so that I can turn it on and off with my voice, which is pretty nice. So y'all have a happy new year. You know, certainly put any comments or suggestions, anything. Really want this to be a community. Like I said, I've learned a lot from guys like the Guitologist and Uncle Doug and D-Lab and El Paso Tube Amps. So just trying to pass along some of these things as I encounter them in my own working on things. Thanks.